guys, Mr. Backwork here. In this video we're going to look at interior angle measures within a polygon. Now one polygon that we should already be pretty familiar with is a triangle. We know that the angles inside of a triangle should add up to 180 degrees. But what happens if we start building bigger shapes like a quadrilateral or a pentagon or a hexagon? Then what do the angles inside of the figure have to add up to be? Let's first look at a quadrilateral, and I'm going to draw out a square. And let's figure out what the degree measure of a square has to be. Okay, now what I'm going to do is I'm going to take this square and I'm going to split it up into a couple of pieces. I'm going to connect these two opposite vertices, and what that does is it splits our quadrilateral into two triangles. Now we already know that the angles inside of a triangle have to add up to 180 degrees. So in this bottom triangle that has to be 180 degrees, and in this top right triangle that also has to be 180 degrees. So if we take 180 plus 180, we end up with a total of 360 degrees. Now let's take that a next step further for a pentagon. Okay, I'm going to split this pentagon up into a bunch of triangles again. With a pentagon, we can split that into three triangles. So we've got 180, 180, and 180. Well, if we add all those together, we should get 540 degrees. So the angles inside of a pentagon add up to 540 degrees. What if we did a hexagon? Okay, hexagon has 6 sides. I'm going to split this up into triangles again. Now we can make 4 triangles within this hexagon. So if we go 180 plus 180 plus 180 plus 180, we're going to end up with 720 degrees. Okay, but there's a shorter way to do this instead of drawing out each picture and splitting it up into a bunch of triangles. We've got a formula that we can use. Here's our formula. It's S sub I, which means the sum of the interior angles is equal to n minus 2 times 180. N is going to represent the number of sides that a figure has. Okay, so what we do is we take the number of sides, minus 2, and then multiply that by 180. Where that's coming from is the number of triangles that we can create from each figure. In a quadrilateral, a 4-sided figure, we could create 2 triangles. So 4 minus 2, we had 2 triangles. In a pentagon, 5 sides, we could have 3 triangles. 5 minus 2 is 3. In this hexagon, 6 sides minus 2 is 4 triangles. Okay, so this n minus 2 is how many triangles can be made within each figure. If we're just looking at a triangle has 3 sides. 3 minus 1 is 1 triangle. So this is the formula that we're going to use to help us figure out the sum of the interior angles, the angles on the inside of a shape, a polygon. So we're going to run through a few examples of finding the sum of the interior angles of specific polygons. Let's start with an octagon. Okay, in an octagon there are 8 sides, so that means we're going to have an n value of 8. Now we're going to use that formula that we just talked about. Let me write it out real quick. We've got n minus 2 times 180, so we have to take this 8 and subtract 2. Let me write this out. 8 minus 2 times 180. Well, if we take 8 minus 2, we're going to get 6. And then if we multiply that by 180 degrees, we end up getting 1,080 degrees. Now next, let's look at a decagon. Okay, a decagon has 10 sides, so an n value of 10. And if we plug that into our formula, we're going to go 10 minus 2 times 180. Well, 10 minus 2 is 8 times 180 degrees. We end up getting 1,440 degrees. Now, last one, let's do a 17gon. Okay, the number of sides is already in the name. We've got 17 sides. So our n value is 17. So we're going to take 17 minus 2 times 180 degrees. If we do 17 minus 2, that's 15. And then 15 times 180 degrees is 2,700 degrees. Now we can also use this formula to work backwards. So let's say we knew the interior angle sum. So here we've got 900 degrees. And we want to figure out what kind of shape is this, or how many sides does this shape have. So I'm going to write out that formula again. So we've got the S sub I equals n minus 2 times 180. Well, if we're given an angle sum, that represents the S sub I value. So we're going to do some substitution. We're going to plug in that 900 for the S sub I. So we've got 900 equals n minus 2 times 180. And what we're going to do is we're going to work on solving to get n all by itself. Right now, n is trapped inside of parentheses by this multiplication that's happening with the 180. So in order to get rid of multiplication, we have to do division. So I'm going to divide both sides by 180. Now on the left-hand side, if we take 900 divided by 180, we get 5 equals, on the right-hand side, those 180s cancel out, so all we have left over is the n minus 2. Now in order to get n all by itself, we have to add the 2. So this figure that we're talking about has 7 sides, and a 7-sided figure we call a heptagon. In this example, we're given most of the angles inside of this figure, and what we want to do is we want to solve to figure out what this x value is. So the first thing we need to do is figure out what kind of shape we're looking at and what its interior angle sum should be. So this one has 4 sides to it, makes it a quadrilateral. Inside of every single quadrilateral, there should be 360 degrees. Okay, that should be the sum of the interior angles. So let's look at what we've got. We've got 110, 120, and 60. The first thing that I'm going to do is I'm going to add up all of the angles inside of the triangle because we know that those should add up to 360. So I'm just going to start adding the interior angles together. Now if we combine like terms on the left-hand side with these 3 angle measures that we know, 110 plus 120 plus 60 is 290. So we've got 290 plus x equals 360. Now all we have to do is subtract that 290 over to the other side to figure out our x value. When we do that subtraction, 360 minus 290, we should get an x value of 70 degrees. The last thing I want to talk about in this video are angle measures within regular polygons. So if you remember, a regular polygon is a shape that's got all congruent sides and all congruent angles. So we've already been talking about the sum of interior angles within any kind of polygon. Could be a regular polygon, might not be. But let's say we wanted to talk about just one specific angle within a regular polygon. Let's start off with a triangle. We know that the angles inside of a triangle have to add up to 180 degrees. But let's say this was a regular triangle where all the sides are congruent and all the angles are congruent. And let's say we wanted to find the measure of just one of those angles. Then what we would do is we would take that interior angle sum of 180 degrees and divide it equally amongst the 3 angles. So if we take 180 divided by 3, we get 60 degrees as each interior angle. Now if we did something similar with a quadrilateral, okay, a square is a regular quadrilateral. All the sides are congruent and all the angles are also congruent. So if we're looking at this square, the interior angle sum has to be 360 degrees. And if we're going to split that up equally amongst the 4 angles that happen inside of that figure, then we end up with 90-degree angles. So if we continue this pattern onto a pentagon, if we want to have congruent angles inside of this regular pentagon, then we're going to take the sum of the interior angles, which ends up being 540 degrees, and we have to divide it by the number of angles. So we're going to divide it by 5. So if we take 540 divided by 5, we end up with 108 degrees. But what we can do is we've got a formula that we can use for this. Now we've already been talking about the sum of the interior angles. That's our n minus 2 times 180 formula. And what we've been doing this whole time is we've been dividing by the number of sides. And we used n to represent the number of sides. So I'm going to put that over n, and I'm going to call this formula I. This is one interior angle in a regular polygon. We take the sum of the interior angles, n minus 2 times 180, and we divide it by the number of sides, n. That's going to be it for this video. Thanks for watching.